So if A and B are invertible matrices, then A times B is invertible. How do you show that a matrix is invertible? So you find the inverse, right? So, do I have to do a separate proof for when I show that A times B is invertible? Not if I find the inverse, I don't, right? So if I find the inverse of A times B, I'm showing that it exists, right? So I'm showing that it's invertible. So let's see.
So how is this proof different than the one that we just did?
How is this proof? The proof that we just did showed that the inverse is unique. This has to do with the inverse of a product of two matrices. Okay, so I have to show that the inverse of A times B is equal to B inverse A inverse. Of course, the conditions are also important. But let's see. You heard what I said? I said the inverse of A times B. So why don't I write that in words? Instead of this notation, I'm going to write it out in words. So I have to show that the inverse of AB is this guy. So how do I show that these two matrices are inverses of each other? What do I have to do?
Proof, and I'm not sure which method of proof.
It's going to be a direct proof. But what is the definition of the inverse of a matrix? It's a matrix that when multiplied by the original matrix, it gives you what? The identity. Okay, so what do I have to do to show that these two guys are inverses of each other?
Multiply them by each other.
Thank you. Okay, so we're going to multiply them together. So we have to multiply them both ways, right? Just to make sure. So we must show that this times this equals the identity, and if you multiply them the other way around, it also equals the identity. Okay, so let's multiply. Let's see, AB times B inverse, A inverse. Let's see, what are we allowed to do with matrices? We can't move them around, but we can move what around? The parentheses, because matrix multiplication is associative. Okay, so the associative property of multiplication of matrices allows me to do this. Right? Okay, so I know B times B inverse is equal to the identity. Does it matter which matrix you group the identity with when you multiply it? Not really. So you can multiply it times the A if you want. It goes away, right? It's up to you. Okay, so this means this is equal to A times A inverse. You know A inverse is the inverse of A, so that means A times A inverse is the identity. Okay, so we showed that AB times its presumed inverse is equal to the identity. I have one more thing to do. Next I have to show that B inverse A inverse times AB equals the same thing. So that's one part of the proof. Okay, so again, by the associative property, I'm allowed to group A inverse and A together, which means this is the same as B inverse times the identity times B. I can group the first two together, it doesn't matter how. And this means this is equal to B inverse B, which is equal to the identity. So I multiplied the AB on the left, I got the identity. I multiplied AB on the right, I got the identity. So then you say, therefore, B inverse A inverse is the inverse of AB. This has some notation. This means the inverse of AB is B inverse A inverse. Nice and short, right? No big surprises, hopefully.